In this presentation, we will talk about what text mining is and what data can utilize it with to answer our research questions. Text mining is the process of turning large quantities of text into useful information. Text data is unstructured and therefore must be pre-processed in order for us to mine the useful knowledge. Much of the data created by people is text, and so there is lots of text available. Using text mining, we can gain insights about this plentiful data type. We can better understand the need for text mining with an example. Let's say a doctor has a patient with a strange medical case with a combination of symptoms that he or she is unsure of. To look more into this problem, the doctor has to refer to the Medline database. This database contains 25 million papers that he or she would have to read in order to help determine what disease this patient has. With that much reading to do, they would before he figured out what condition the patient has. With text mining, though, we can consolidate the papers that are closer to the disease in question, and the doctor can find the answer faster. There are many research papers written on this topic, so if you look in Google Scholar for text mining and the Medline database, you can follow up on this example. Now, there are many other uses of text mining. Text mining isn't just useful in healthcare. It is used in just about every industry, which is why I thought it would be good for us to work on in this class, because regardless of the background you are coming from, some form of text mining can probably be used in your industry. First, risk management. No matter the industry, insufficient risk analysis is often a leading cause of failure. This is especially true in the financial industry, where adoption of risk management software based on text mining technology can dramatically increase the ability to mitigate risk, enabling complete management of thousands of sources and petabytes of text documents, and providing the ability to link together information and be able to access the right information at the right time. With knowledge management, not being able to find important information quickly is always a challenge when managing large volumes of text documents. Just ask anyone in the health industry. Here, organizations are challenged with a tremendous amount of information. Decades of research in genomics and molecular techniques, for example, as well as volumes of clinical patient data that could potentially be useful for their largest profit center, new product development. Here, knowledge management software based on text mining offers a clear and reliable solution for the info glut problem. Cybercrime prevention. The anonymous nature of the internet and the many communication features operated through it contribute to the increased risk of internet-based crimes. Today, text mining intelligence and anti-crime applications are making internet crime prevention easier for any enterprise and law enforcement or intelligence agencies. For the customer care service, Text mining, as well as natural language processing, are frequent applications for customer care. Today, text analytics software is frequently adopted to improve customer experience using different sources of valuable information, such as surveys, trouble tickets, and customer call notes to improve the quality, effectiveness, and speed in resolving problems. Text analysis is used to provide a rapid, automated response to the customer, dramatically reducing the reliance on call center operators to solve problems. Also, in fraud detection through claims investigation, text analytics is a tremendously effective technology in any domain where the majority of information is collected as text. Insurance companies are taking advantage of text mining technologies by combining the results of text analysis with structured data to prevent frauds and swiftly process claims. Contextual advertising or digital advertising or advertising technology, synonymous words. Digital advertising is a moderately new and growing field of application for text analytics. Here, companies such as Admantix have made text mining the core engine for contextual retargeting with great success. Compared to the traditional cookie-based approach, contextual advertising provides better accuracy and completely preserves the user's privacy. Business intelligence. This process is used by large companies to uphold and support decision making. Here, text mining really makes the difference, enabling the analyst to quickly jump at the answer even when analyzing petabytes of internal and open source data. Applications such as the Cogito Intelligence Platform, CIP, are able to monitor thousands of sources and analyze large data volumes to extract from them only the relevant content. Content enrichment. While it is true that working with text content still requires a bit of human effort, text analytics techniques make a significant difference when it comes to being able to more effectively manage large volumes of information. Text mining techniques enrich content, providing a scalable layer to tag, organize, and summarize the available content that makes it suitable for a variety of purposes. Something we all use frequently, spam filtering in our email. Email is an effective, fast, and reasonably cheap way to communicate, but it comes with a dark side, spam. Today, spam is a major issue for internet service providers, increasing their costs for service management and hardware-software updating. For users, spam is an entry point for viruses and impacts productivity. Text mining techniques can be implemented to improve the effectiveness of statistical-based filtering methods. Lastly, social media data analysis. Today, social media is one of the most prolific sources of unstructured data. Organizations have taken notice. Social media is increasingly being recognized as a valuable source of market and customer intelligence, and companies are using it to analyze or predict customer needs and understand the perception of their brand. And both needs, text analytics can address both by analyzing large volumes of unstructured data, extracting opinions, emotions, and sentiment, and their relations with brands and products. So some challenges in text mining. First is unstructured data. or unstructured information is information that either does not have a predefined data model or is not organized in a predefined manner. Unstructured information is typically text-heavy, but may contain data such as dates, numbers, and facts as well. This results in irregularities and ambiguities that make it difficult to understand using traditional programs as compared to data stored in fielded form in databases or annotated, semantically tagged in documents. It is predicted that by 2025, we will have 163 zettabytes of data, most of which will be unstructured. In numerical analysis and scientific computing, a sparse matrix or sparse array is a matrix in which most of the elements are zero. In text mining, we will be generating sparse matrices due to how the words are separated out. This assists us in being able to do advanced analysis, but also creates problems inherent in sparse matrices. Text mining can examine single words or phrases, which can complicate how the text is analyzed. The context of how a word is used changes the meaning of the word, hence, contextual analysis will be needed in order to gain more information about the text we are interested in. Just like in all sorts of data analysis, noisy or dirty data can affect our analysis. For example, a misspelled word in the text. The pre-processing of raw data includes raw text tokenization, case conversion, removal of stop words, and stemming. First, the raw text is divided into tokens, which are single words or special symbols, etc. The second step is case conversion, where the words are modified to be all in lower case. All the capital letters will be converted into lower cases. The third step is the removal of stop words. The purpose of stop word removal is to reduce the size of the classification matrix by reducing the number of irrelevant terms. Lots of very commonly used words like the, I, to, etc. are of little use in classifying documents into predefined categories. The efficiency and accuracy of the classifications can be improved by removing these words. The final pre-processing step is stemming. Different variations of a word are converted into a single common form that is termed stem. Usage of stemming significantly reduces the number of features and increases retrieval performance. This data is then stored in a document term matrix, which is the sparse matrix we were just talking about. The result so far is a term by document matrix, which each cell representing the raw frequencies of occurrence for each term in each document. The columns of the matrix represent terms, words, and the rows represent documents, such as online reviews. Each row would be a different online review. There is significant improvement in retrieval performance by using weighted term vectors. The term weight is generated by multiplying term frequency and the inverse document frequency. The large attribute dimensionality incurs high computational costs and can cause overfitting problems in the classification process. So we need to reduce the dimensionality. After the dimensionality is reduced, we can use some sort of analytical model, such as a support vector machine, to classify the text. The text mining workflow starts with a problem definition. Back to our example, a doctor needs to retrieve only relevant articles on an unknown disease. There is an unorganized state of over 25 million articles in the Medline database. The documents need to be organized so that we can extract features to do our analysis on. In this case, classifying the documents in a way that the doctor can quickly identify the possible diagnosis. In the end, we will have organized the articles to help provide insight to the doctor. Tokenization is the process by dividing the quantity of text into smaller parts called tokens. Alternatively, tokenization is the process of breaking up the given text into units called tokens. The tokens may be words or numbers or punctuation marks. Tokenization does this task by locating word boundaries. Tokenizing general English sentences is relatively straightforward. Dictionary-based sentiment analysis is a computational approach to measuring the feeling that a text conveys to the reader. In the simplest case, sentiment has a binary classification, either positive or negative, but it can be extended to multiple dimensions such as fear, sadness, anger, joy, etc. This assists with contextual analysis. We run our text against a predefined dictionary and generate sentiment scores based on the text, which is then stored as a linked list. Types of text mining. Semantic parsing is the kind of text mining where our goal is to separate the sentence into its parts of speech. Semantic parsing follows a tree structure to continually break up the text. We start with breaking the sentence down into a noun phrase and a verb phrase. Then we break each of those phrases down into the individual word types, such as verb, article, adjective, or noun. We now have features both on word type and word order. Thus, this type of word tagging is feature-rich. In contrast, the bag of words method does not care about word type or order. Words are just attributes of the document. Semantic parsing is the task of converting a natural language utterance to a logical form, a machine understandable representation of its meaning. Semantic parsing can thus be understood as extracting the precise meaning of an utterance. However, we will be focusing more on the bag of words technique. The bag of words model is a way of representing text data when modeling text with machine learning algorithms. The bag of words model is simple to understand and implement and has seen great success in problems such as language modeling and document classification. A bag of words model, or BOW for short, is a way of extracting features from text for use in modeling, such as with machine learning algorithms. The approach is very simple and flexible, and can be used in a myriad of ways for extracting features from documents. A bag of words is a representation of text that describes the occurrence of words within a document. It involves two things: a vocabulary of known words and a measure of presence of known words. It is called a bag of words because any information about the order or structure of words in the document is discarded. The model is only concerned with whether known words occur in the document, not where in the document. The intuition is that documents are similar if they have similar content. Further, that from the content alone we can learn something about the meaning of the document. The bag of words can be as simple or complex as you like. The complexity comes both in deciding how to design the vocabulary of known words or tokens and how to score the presence of known words. We will take a closer look at both of these concerns. Let's make the bag of words model concrete with a worked example. Step 1, collect data. Below is a snippet of the first few lines of text from the book A Tale of Two Cities by Charles Dickens, taken from Project Gutenberg. It was the best of times. It was the worst of times. It was the age of wisdom. It was the age of foolishness. For this small example, let's treat each line as a separate document, and the 4 lines as our entire corpus of documents. A corpus is a collection of written texts, especially the entire works of a particular author or a body of writing on a particular subject. In text mining, the corpus represents a collection of data text labeled with text annotations. It is equivalent to a dataset and other forms of analysis. Now we can make a list of all of the words in our model vocabulary. The unique words here, ignoring case and punctuation, are it, was, the, best, of, times, worst, age, wisdom, foolishness. That is a vocabulary of 10 words from a corpus containing 24 words. The next step is to score the words in each document. The objective is to turn each document of free text into a vector that we can use as input or output for a machine learning model. Because we know the vocabulary has 10 words, we can use a fixed length document representation of 10, with one position in the vector to score each word. The simplest scoring method is to mark the presence of words as a Boolean value, where 0 means the word is absent and 1 means the word is present. Using the arbitrary ordering of words listed above in our vocabulary, we can step through the first document. It was the best of times, and convert it into a binary vector. The scoring of the document would look as follows. It equals 1, was equals 1, the equals 1, best equals 1, of equals 1, times equals 1, worst equals 0, age equals 0, wisdom equals 0, and foolishness equals 0. As a binary vector, this would look as follows. 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. The other 3 documents would look as follows. All ordering of the words is nominally discarded, and we have a consistent way of extracting features from any document in our corpus, ready for use in modeling. New documents that overlap with the vocabulary of known words, but may contain words outside of the vocabulary can still be encoded, where only the occurrence of known words are scored and unknown words are ignored. You can see how this might naturally scale to large vocabularies and larger documents. You can also see how we would end up with very sparse matrices if, in this instance, is just a vector, but you can see there's already 4 zeros. If we looked at a much larger matrix of larger documents with multiple sentences, you could see how you could end up with a matrix with very many zeros. Hence, why sparse matrices become a problem in text mining. As the vocabulary size increases, so does the vector representation of documents. In the previous example, the length of the document vector is equal to the number of known words. You can imagine that for a very large corpus, such as thousands of books, that the length of the vector might be thousands or millions of positions. Further, each document may contain very few of the known words in the vocabulary. This results in a vector with lots of zero scores, called a sparse vector or a sparse representation. Sparse vectors require more memory and computational resources when modeling, and the vast number of positions or dimensions can make the modeling process very challenging for traditional algorithms. As such, there is pressure to decrease the size of the vocabulary when using a bag of words model. There are simple text cleaning techniques that can be used as a first step, such as ignoring case, ignoring punctuation, ignoring frequent words that don't contain much information called stop words like a, of, etc., fixing misspelled words, reducing words to their stem, example, play from playing, using stemming algorithms. A more sophisticated approach is to create a vocabulary of grouped words. This both changes the scope of the vocabulary and allows the bag of words to capture a little bit more meaning from the document. In this approach, each word or token is called a gram. Creating a vocabulary of two word pairs is in turn called a bigram model. Again, only the bigrams that appear in the corpus are modeled, not all possible bigrams. Sometimes we can find out the author's intent and main ideas just by looking at the most common words. At its heart, bag of words text mining represents a way to count terms, or n-grams, across a collection of documents. A unigram is a single word, bigram is a two-word phrase, and an n-gram is just any specified number of terms. Commonly, we will want to break our document down into the individual terms, or unigrams, and then count those terms. This frequency will tell us which words are the most used and most relevant. We can use this to create a word cloud, which is a data visualization commonly used in marketing to show word importance relative to a brand. We will talk more about this soon. For example, the bigrams in the first line of text in the previous section, "It was the best of times," are as follows. It was the best, best of times. A vocabulary then tracks triplets of words is called a trigram model, and the general approach is called the n-gram model. where n refers to the number of grouped words. Often, a simple bigram approach is better than a unigram bag of words model for tasks like document classification. Once vocabulary has been chosen, the occurrence of words in example documents needs to be scored. In the worked example, we have already seen one very simple approach to scoring: a binary scoring of the presence or absence of words. Some additional simple scoring methods include counts, count the number of times each word appears in a document, or frequencies, calculate the frequency that each word appears in a document out of all the words in the document. You may remember from a computer science class that a hash function is a bit of math that maps data to a fixed size set of numbers. For example, we use them in hash tables when programming, where perhaps names are converted to numbers for fast lookup. We can use a hash representation of known words in our vocabulary. This addresses the problem of having a very large vocabulary for a large text corpus, because we can choose the size of the hash space, which is in turn the size of the vector representation of the document. Words are hashed deterministically to the same integer index in the target hash space. A binary score or count can then be used to score the word. This is called the hash trick or feature hashing. The challenge is to choose a hash space to accommodate the chosen vocabulary size to minimize the probability of collisions and trade off sparsity. A problem with scoring word frequency is that highly frequent words start to dominate in the document. Example given, larger score, but may not contain as much informational content to the model as rarer but perhaps domain-specific words. One approach is to rescale the frequency of words by how often they appear in all documents, so that the scores for frequent words like the that are also frequent across all documents are penalized. This approach to scoring is called term frequency inverse document frequency, or TF-IDF for short, where term frequency is a scoring of the frequency of the word in the current document. The inverse document frequency is a scoring of how rare the word is across documents. The scores are a weighting where not all words are equally as important or interesting. The scores have the effect of highlighting words that are distinct, contain useful information in a given document. Some limitations of bag of words. The bag of words model is very simple to understand and implement and offers a lot of flexibility for customization on your specific text data. It has been used with great success on prediction problems like language modeling and document classification. Nevertheless, it suffers from some shortcomings such as vocabulary. The vocabulary requires careful design, most specifically in order to manage the size, which impacts the sparsity of the document representation. Sparsity. Sparse representations are harder to model both for computational reasons, space and time complexity, and also for information reasons, where the challenge is for the models to harness so little information in such a large representational space. The meaning, discarding word order, ignores the context, and in turn, meaning of words in the document, semantics. Context and meaning can offer a lot to the model, that if model could tell the difference between the same words differently arranged, this is interesting versus is this interesting? Synonyms like old bike versus used bike, and much more. There are many places we can obtain data from in order to do our analyses. Social media analytics focuses on collecting data from Facebook, Twitter, Instagram, LinkedIn, or other websites like Reddit. We can use a programming language called Python to automatically collect all the data from these sites through the use of the website's API, or Application Programming Interface. Through government regulation, Facebook and Instagram have become rather hard to get data from. However, Twitter is still relatively easy to get data from. If you are interested in human resources, then getting data from LinkedIn might be useful. Reddit is another online forum type site that is pretty easy to get data from. Most any online forum may be a useful source of information. I have done research on the airline customer satisfaction online forums, as well as online health communities for patients with diabetes. Realistically, with a tool called Parsub, you can scrape data from any website you can find. Parsub is a free and easy to use software that allows you to scrape data from just about any website. We will be doing the tutorial for this software in this class. My main goal is that everyone can easily get a source of data to work on their conference paper for this class. Sometimes, though, we would like to get more advanced data from the website. If you want to get your data from Twitter or Reddit, then I can help you with some scripts that I already have written. I suggest that you read up on Twitter analytics before you take this route. You need a very defined research question before you start pulling data down from Twitter. Python is a general purpose and high-level programming language. You can use Python for developing desktop GUI applications, websites, and web applications. Also, Python, as a high-level programming language, allows you to focus on core functionality of the application by taking care of common programming tasks. It is heavily used in data science and technology applications and is well worth learning if you are going in that direction. Creating variables from text. Now that we have a source of data, what can we do with that data? The simplest variable we can find on a document is the text length. Text length can be used to predict the helpfulness of the text, as in the more number of words, the more helpful the text is. Once we have cleaned up our text and performed some basic word frequency analysis, the next step is to understand the opinion or emotion in the text. This is considered sentiment analysis. There are several lexicons that we can compare to gain an understanding of the text. Neutral text sentiment is often found to be more helpful. The information entropy, often just entropy, is a basic quantity in information theory associated to any random variable, which can be interpreted as the average level of information, surprise, or uncertainty inherent in the variable's possible outcomes. Information entropy is also used to determine the uniqueness, unpredictability of the text, which indicates that the text is more helpful. The Automated Readability Index outputs a number which approximates the grade level needed to comprehend the text. For example, if the ARI outputs the number 3, it means students in 3rd grade, or roughly ages 8 to 9 years old, should be able to comprehend the text. These are just a few variables that can be derived from text, all of which I have found by reading the literature that I supplied for you on Blackboard. Sentiment analysis. All three of these lexicons are based on unigrams or single words. These lexicons contain many English words, and the words are assigned scores for positive or negative sentiment, and also possibly emotions like joy, anger, sadness, and so forth. The NRC lexicon categorizes words in a binary fashion, yes or no, into categories of positive, negative, anger, anticipation, disgust, fear, joy, sadness, surprise, and trust. The Bing lexicon categorizes words in a binary fashion into just positive or negative categories. The AFIN lexicon assigns words with a score that runs between -5 and 5, with negative scores indicating negative sentiment and positive scores indicating positive sentiment. Like I said on the last slide, if we are trying to determine the helpfulness of the text, the more neutral the sentiment, the more helpful the text is. This might be useful if you are doing research on online reviews. Some other kinds of analysis. So we can visualize all three of the lexicons. Let's see, come back to latent semantic analysis and singular value decomposition are some more advanced analyses. If you go that route, then I think it would be best to do some research on it and then come talk to me if you want to do some more advanced analysis beyond what most of the other research topics will be. We can also visualize text data with the use of tag clouds or word clouds. After you have cleaned and pre-processed your text, you can obtain a word cloud where the larger the word, the more frequent the term. You can also use frequency tables or bar graphs, but the word cloud is quite common right now, especially in marketing. For the purpose of this class, you will start with an annotated bibliography and literature review. This will help you determine your research question. Once you have an idea of what you will write your paper on, you will need to determine where and how you will get the data. You will then collect the data and perform some kind of analysis or develop a model. Then you will determine the theoretical, methodological, or practical implications for your research. I would like everyone to then send their paper to a conference that will be here in Jacksonville in February of 2021. SEDSI is the Southeastern Decision Science Institute. They have an annual conference in February of every year. And in 2021, it just happens to be in Jacksonville. The paper itself won't have to be submitted till December, so you should have plenty of time to get your conference paper set up and sent, I would like you, this is the link to the history, and I would like you to take a look at the kinds of papers being published in the proceedings. The link will take you to the proceedings. This will also allow you to get feedback on your research, which will hopefully be helpful to you finishing your dissertation. I will give you feedback on your papers, but when you send a paper to a conference, then you should get at least 2 other people that will review your paper and give you additional feedback to help shape your paper. Conference papers, usually around 10 pages, and you just want to put enough of your idea out there to get good feedback, and then ideally with that feedback, and if you go and present the paper, you'll get additional feedback and ideas. You can make the paper better, and then you can send it to a journal to be published. Well, you also get a conference paper published by sending it there. So that is the main goal of this class, and text mining should give you a quick way to get data, analyze it, and get a research stream going. So